there's two types of calculations that we run into in Chapter 18. One is molarity, calculating molarity given grams and you have to convert to moles, or given milliliters and you have to convert to liters. The other is dilutions. If you have a concentrated solution and you want to get it down to a certain molarity, you have to use the dilution formula to figure out how much water to add or solvent to add to dilute it down. Let's do a molarity calculation first. Now remember, molarity is moles per liter. Moles of solute per liter of solution. Okay, and that comes into play when you do molarity calculations. Let me give you an example. Question 1 asks, what is the molarity of 0.945 liters of a solution that contains 0.227 moles of iron nitrate, iron 3 nitrate? Okay, well, let's put down what they're telling us. They're telling us that we have 0.227 moles of our iron nitrate okay, and it's in 0.945 liters of solution. Okay, so this much solute in this much solution. To calculate the molarity, which is moles per liter, I just simply divide in this case. I take 0.227 divided by 0.945. So let's do that. .227 divided by 0.945 gives me 0.24. So that would equal 0.24 molar. The big M is for molarity. And that's how you solve one of those problems. If they give it to you in moles and they give you the liters of solution, it's just really straightforward. Molarity is moles per liter, you just divide. But it's usually they don't give it to you that straightforward. Okay, oftentimes they give you the solute in grams instead of moles. Well, in that case, you got to convert. Then you got to use the periodic table to do that, because the masses, the atomic masses on the periodic chart, that's the number of protons and neutrons in the nucleus, the weight of those. That is the weight of 1 mole, and that's useful. Whenever you're converting from grams to moles, you can use that fact to figure molarity. Okay, let me give you an example of what I'm talking about. The next question asks, what is the molarity of a solution that contains 50 grams of sodium hydroxide in 855 mLs of solution? Okay, so let's first write down what they're telling us. The problem says we have 50 grams of sodium hydroxide, and it's dissolved in 855 milliliters of solvent. Okay, and they want to know the molarity. Well, molarity is moles per liter, so we have to get the numerator into moles and the denominator into liters, and then we can divide it. Okay, so let's start with the numerator. If I have 50 grams of NaOH, I need to know how many moles that is. Well, I can look that up on my periodic table. I can add up all the atoms in the molecule. Okay, the sodium plus the oxygen plus the hydrogen, and the combined weight of all the atoms in that molecule is the weight of 1 mole of sodium hydroxide. Okay, so let's do that. Sodium, molecular weight, it's in column 1, group 1A, and I see the molecular weight is 22.990. Okay, oxygen is in group 6A, and it is 15.999. And hydrogen is group 1A, it's the first element, 1.0079. The combined weight is going to be the weight of 1 mole of sodium hydroxide. So let's add those up. Okay, 22.990 plus 15.999 plus 1.0079 gives me 39.9969, or I'm going to round it to 40. 40 atomic mass units, or 40 grams per mole, or 40 grams per mole. That's right. So that's what that would mean. 40 atomic mass units, same thing as 40 grams in 1 mole of sodium hydroxide. That's useful information, because now what I can do, let me erase all of this, is I can set up a simple conversion. If I have 50 grams of NaOH, and I know that 40 grams of NaOH is the weight of 1 mole, okay? To solve this, I multiply across the top first, and then I divide up. So 50 times 1 is 50, divided by 40 is 1.25. And now my grams of sodium hydroxide cancel, and I get moles. That's moles of sodium hydroxide. Okay, so now my answer would be 1.25 moles of sodium hydroxide. Okay, that goes in my numerator. Because if they want to know molarity, I need to know moles, and they give it to me in grams, so I had to convert it. Okay, so I've got 1.25 moles of NaOH in 855 mLs of solution. Well, I need it in liters, and a milliliter is 1,000 liters. So I can take my decimal point, which in a whole number is at the end, and I can move it 3 to the left. Okay, and that gives me 0.855 liters. Okay, now I've got the numerator in moles, from grams to moles. I've got the denominator in liters, from milliliters to liters. I just simply divide 1.25 divided by 0.855, and I get 1.46. And that's 1.46 molar. Big M for molar, because it's in moles per liter. So the question started out asking me, what is the molarity of a solution that contains 50 grams of sodium hydroxide in 855 mLs of water? Well, the molarity is 1.46 molar solution. Okay, let's try one more of those. This one's a little bit more complicated. It says, what mass, so they want to know a weight in grams when they ask you mass, of zinc nitrate, and zinc nitrate looks like this. The formula for zinc nitrate is, so it's zinc 2 nitrate, is needed to prepare 675 milliliters of a 1.2 molar zinc nitrate aqueous solution. So they want me to make 675 milliliters, okay? And they're telling me I've got 1.2 molar, I want to prepare a 1.2 molar zinc nitrate solution. So I need to figure out how many moles, okay, that is. How many moles of zinc nitrate? And then I can convert it to grams using the formula weight, because I know the formula, so I can add up all the atoms in that molecule and figure out the formula weight. So let's do the first step. I have 675 mLs, okay? And they want me to make a 1.2 molar solution. Well, 1.2 molar is the same thing as 1.2 moles in 1 liter. Okay, so I have to convert this. I can see right off the bat I need these units to cancel, so they have to be in the same units. So I have to convert this to liters. And I do that by moving my decimal 3 to the left, because 675 milliliters is the same thing as 0.675 liters, because a milliliter is 1,000th of a liter. Or there's 1,000 milliliters in 1 liter, I should say. So I move it 3 to the left. Now that can cancel, the liters cancel, and I'll end up in moles. I multiply across the top and divide up. So 0.675 times 1.2 gives me 0.81, and that's moles, okay, because I'm now in moles. So I need 0.81 moles of zinc nitrate to make up this solution. Well, I can't weigh out. There's no scale that gives you the weight in moles. It's in grams. So I got to figure out, okay, how much does 0.81 moles of zinc nitrate weigh, zinc 2 nitrate? Well, we can figure that too. What we've got to do is take that 0.81 moles and we have to figure out how many grams 1 mole of zinc nitrate weighs. Back to the periodic table. Find zinc, and zinc is element number 30 right here. It weighs 65.39. Okay, so I've got 1 zinc in this formula. In this molecule, I've got 1 zinc atom. I've got 2 nitrates, so I have to double everything in the parentheses. So I have 2 nitrogens and 6 oxygens. Okay, nitrogen right here, group 5A, weighs 14.007 times 2, and oxygen weighs 16 times 3. Okay, add that all up, and I get 65.39 plus 14.007 plus 14.007. It gives me 28.077, and then 3 times 16 is 48. Add those all up. 65.39 plus 28.077 plus 48. $141.47. We'll round that to grams. Okay, so that's what that tells me is 141.47 grams of zinc nitrate makes up 1 mole. Okay, we just add that again. Check my math. 20.77 plus 48. Yeah. So I put 141.47 grams in 1 mole. My moles cancel. I multiply across the top and divide up. So it's that times 0.81. And that gives me 114.59. Now I'm in grams. Okay, and that's what the question asked me. It said, what mass of zinc nitrate, well, mass is grams, is needed to prepare 675 milliliters of 1.2 molar zinc nitrate aqueous solution? Well, the answer to that is 114.59.